Okay, so this is sort of a boost or hint for the last semester in physics problem to test if you really are good at solving physics tricks. I've got set up here, incline, block 2 I think is on the ramp, block 1 is free falling. These are all the givens. I think they're scrambling, I don't know, the same ones. So what we're going to do is we're going to first start with free body diagrams and try and identify all the forces. So for object 1, the forces that we have acting on object 1 are the force of gravity, which for this object is going to be 0.7 times 10, so 7 newtons. And then there is some tension up. It is unknown. It is accelerating downward, which means this is being pulled up the ramp. So we can assume that the gravity is larger than the tension. We don't know exactly what it is yet. That's for object 1. Free body diagram for number 2. This one over here. A little bit trickier. Since it's on an incline, again we have gravity pulling it straight down, and we have the tension pulling it up the ramp, and this gravity is into two components, part of which is pulling it down the ramp, Fgx, and part of it is the normal force. And so we have this free body diagram and this one. We also have friction. I'm going to draw it out here just to keep it all in line. It's acting in the same direction as this component of gravity, holding it against the tension pulling it up the ramp. So if we're looking at this sort of like we did with the one on a flat table or even on a pulley, basically we need to find out what is causing the acceleration. We know it accelerates at 5 meters per second squared. So really, if we consider the external forces, meaning let's forget about tension for just a little bit, and let's just say, what are the external forces that are acting on this? Well, force of gravity is pulling one way, and this dot now, make it a little bigger, represents our system, and pulling back the other way is the force of gravity, X component, this component right here, which is this part of gravity at point 9, and friction. You can see that if we knew this mass, all this would be really easy. But we can start to think of these things in terms of math, or in terms of variables, and that's why it's been good to practice writing these equations as variables, as it's had to do with a couple problems. So really we can say the net force, or the sum of the forces, is equal to Fg of 1, right, symbolize it, or note that way, minus Fg2x plus force of friction. Oops. And so now we can just start breaking this apart a little bit. Okay, so this is equal to 7 newtons minus Fg of x. So what is that? Well, that's going to be M2. Fg is going to be, of 2 is going to be M2 times 10 meters per second squared. But the x component, and since the x component is opposite of the angle that we know, this is our angle 30 degrees here. Since it's opposite, it's going to be F2 sine of 30, and then because it's minus another plus, we're now going to have the force of friction, which friction is mu times the force of normal force of friction, or it's a fun equation. It's so much fun to write, so we'll just write times the normal. And so we can say here, okay, friction, mu, easy, right, that's given to us 0.4 times the normal force. Well, the normal force here is going to be the y component of Fg2. So the y component is going to be Fg again, so M times 10 times cosine of 30. So now we can figure out the net force. This is going to be good because what we're going to use in the end, just like with the pulley, I ran out of room, sorry that got so small there, let me read it to you. So 7 newtons minus mass 2 times acceleration due to gravity times sine of 30 minus 0.4, which is our mu, times mass 2 times 10, again this is force of gravity on 2, times cosine of 30, and that gives us this for normal, this for the weight that's pulling it down. So if we were to talk about these things, right, this is gravity pulling mass 1 down, this is the weight component that's holding it back, and this is the friction that's holding it back. So now we can go and we can use Newton's second law, which says acceleration is directly proportional to the net force and inversely proportional to the mass. And we can start to think about this just like we did with the problem on the board that we also worked in class. And acceleration is our net force, which is all this, 7 newtons minus m2 times 10 times sine of 30 minus 0.4 times m2 times acceleration due to gravity times cosine of 30 divided by the mass that accelerates. And what mass accelerates? Well, the whole thing acts as a system. Remember just how we talked about on the board that's pulling along the table, these two are hooked together, so you got to consider them as a single system here. And so we have to add those two masses together. So it's M1 and M2. M1 is 0.7 kilograms plus M2. And we know that our acceleration is 5 meters per second. So all of this is equal to 5.0 meters per second squared. And so now what we've got here is we have one huge equation with one unknown. The unknown is mass 2. I'll leave you with that. See if that helps you.